In section 7.1, you worked with exponential functions. In section 7.2, you worked with inverse functions. And in section 7.3, you're going to put exponential functions and inverses together. So what I want you to be able to do is write equivalent forms of exponential and logarithmic functions, and to write, evaluate, and graph logarithmic functions. So let's just talk about what a logarithm is first. A logarithm is the exponent to which a specific base is raised to obtain a given value. So you can think of a logarithm as an exponent. You can write an exponential equation as a logarithmic equation, and you can also write a logarithmic equation as an exponential equation. So here is something that shows you how to convert from an exponential equation back to a logarithmic equation. It's really quite easy. You need to, so you can switch from one form to the other, and the logarithmic equation is read as the log, and then you always say what the base is because the base will change. So you say log base b of a is x. So here's an example. If we have this logarithmic equation, we read it as log base 2. So again, you have to identify what the base is. Log base 2 of 8 equals 3. Now this is your exponent because logarithms equal the exponent. Now we're going to convert from exponential to logarithmic, and then also from logarithmic to exponential. So when we start out with a base raised to a power equals a number, we're going to change it to logarithmic form. So we first write down log. So I'm going to just go to all three of these and write down log, 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 because I'm changing it from exponential, so a power or a number raised to a power, and we have to identify what the base is. Now the base is whatever's being raised to the power. So I'm going to say log base 3, and remember that the logarithm equals the exponent. So the exponent goes on this side. So it is log base 3 of 9 equals 2. And we can check to see if this is right by saying the base raised to the power equals the number. So is this true? Is 3 squared 9? And it is. So now we'll go to the next one. The base is 4, so we put the base down at the bottom there, down in the basement. And we say log base 4 of 64 equals 3. So checking it, we say 4 raised to the third power equals 64. And the next one, our base is 2, so we say log base 2 of 0.125 equals -3. Now when we go the other way, we're starting with a logarithmic equation and we want it to go to exponential, so we're going to start with the base. So we say the base raised to the power equals the number. So it's kind of like a little swirl. You go from left to right and back to left again. So it's 2 raised to the 4th power equals 16. And this is always has to be a true statement if you've converted correctly from a logarithmic to an exponential. Okay, here again our base is 3. So 3 to the 4th equals 243. And here we have 8 to the 0 power equals 1. And we know that anything to the 0 power equals 1. Okay, so that's how you convert back and forth. Now, since a logarithm is an exponent, the rules for exponents that you learned in section 1.5 also apply. So there's some special properties we'll talk about today, and then tomorrow we'll go into more depth with properties of logarithms. But for right now, just remember that any base, that b has to be greater than 0, and it cannot equal 1, and we talked about why it can't equal 1 the other day. And here is an example of a special property of log. When the bases, you have a log base b of b, that's going to equal 1. So what does that mean? Well, it means when the base is followed by a number that is identical to it, it's going to equal 1. And the reason why, if you look over here, if we take the base and we raise it, if these two are identical, if we take 10, raise it to the first power, you're going to get that back again. It doesn't matter if this is 5 and 5. 5 to the first equals 5. So when you see these two numbers next to each other and they're identical, the exponent is 1. All right, the logarithm of 1. Well, we know that any number raised to the 0 power equals 1. So if you have a base and you raise it to the 0 power, it's going to be 1. So whenever you have a base and there's 1 right next to it, your exponent is going to be 0. So there's an example right here to show you 10 to the 0 power equals 1. So just kind of think those through and they make sense. Common logarithm. A logarithm with a base of 10. So it's the most commonly used logarithm. So if you don't have a base, it's a base 10 is assumed. So let's look at a couple of these here. There's no base on this one, so it's a, oops, I don't want to make that look like a 0. So there's no base here, so we know that it's 10. So we would read this as log base 10 of 100 is 2. And if we want to check that, we can just go 10 squared equals 100. That's exponential form. All right, now we're going to evaluate logarithms by using mental math. So just kind of by evaluating those quickly here. We're assumed that this is a base 10. And I guess what I did is I typed up the same thing twice. So this is going to be basically what you're asking yourself when you want to change this expression to be an exponent. So you're asking yourself 10 to what power equals 100. And we already answered that up above, so that's an easy one. So that's going to equal 2. If we go down to the next one, our base is 10. And now we have a decimal here. So if you have a decimal, then you know that your exponent is going to be a negative number. So all you need to do is count how many places you move the decimal. So 1, 2, 3, 4, 5. So that's going to be, again, a base of 10, and we know that we have to move it, the decimal place, 5 places to the right, so it's going to be 10 to the negative 5th. So kind of look at it like this. 10 to the 0 is 1, and there's 1 0 there when it's raised to the 0 power. 10 to the 0 is 1, and there is no 0. Sorry. Okay, now when we raise it to the first power, we have 1 0. So when we go the other way to the negative power, it's 0.1. All right, now you can also have a base followed by a fraction. And when that happens, if the numerator is 1, the easiest way to do that is to ask yourself, well, what power do I raise 5 to get 5? And the answer is 1, but when we have a fraction, we have to take the reciprocal. So what that does is it changes your exponent from a 1 to a negative 1. So just remember, 5 to the x equals 1/5 is what we want to decide. So if we say 5 to the 1, we know that's 5, but we want it to be 1/5. We want the reciprocal of this. So if we take the reciprocal, then we have to change that exponent from a positive 1 to a negative 1. So same thing down here. This is a 0.04. I just changed it to a fraction, which is 1 over 25, and then it's easier to see what you need to raise your base to. So if I just ignore this for right now, and I say 25, what power do I need to raise 25 to get 25? That's the first power. So that's what I'm doing right here, but I want it to be 1 over 25. So if I take the reciprocal of this, I have to change that exponent from a positive to a negative. So 25 to the negative 1 equals 1 over 25. So my exponent here, I would replace this whole thing with negative 1. I'm not quite sure where to write it here. We'll just put it equals negative 1. And this whole thing right here is going to equal negative 1. And this, we want to replace this logarithm with just the number, so we're just going to write it as 5. So because that's what this equals. And this one is just 2. So replacing each one of these logarithmic expressions with just a number. This one is 2, this one is negative 5, this one is, oops, put a box around the wrong one. This one is negative 1, and this one is also negative 1. right, on the other side there's some more graphing to do, and I'm going to give you the values to put in. Okay, so you can fill in your tables. 4 to the x, if x is 0, of course that's going to be 1 here, and then if it's 1 it's going to be 4, and if it's 2 it's going to be 16. And yesterday we went over inverses, so all we need to do, this is going to be the inverse of the exponential function, and so you're just going to switch all the values of x with all the values of y to find the inverse. And when you graph it, here's your line, y equals x. And you can tell, just kind of picture that in your mind. If you were to fold this function over that line, it would be right on top of here. So exponential functions are inverses of logarithmic functions and vice versa. And we want to just identify the domain of f inverse of x. So we're looking at the x values. The smallest value is 1 over 16. And the largest value is 16. So we want all the numbers in between. And then the range, smallest number is -2, and the largest number is 2. Okay, I'm going to have you fill in some tables below and then evaluate a couple logarithms using mental math.